Good morning, afternoon, or evening, cats and dogs. Today's video is on the lesson 4.1 guided notes on powers and exponents. This is something we've already talked about this year, so this should be a really quick and easy lesson for us to get through. So let's get right to it, and let's start with some key vocabulary. First things first, if I have a power, 3 to the 4th power, the big number 3, big number, is our base. They both start with B. Big number is our base. That is the number that is going to be multiplied. The little number is our exponent. And it tells us how many times the base is used as a factor, how many times it's being multiplied. So 3 to the 4th power is 3 times 3 times 3 times 3. And down in this box, it says the number that can be expressed using an exponent is called a power. In this case, we're talking about 3 to the 4th power. Something that's important that has double stars next to it or double snowflakes down here, although it's pretty warm to talk about snowflakes. Well, I guess it's kind of chilly today. I probably shouldn't say that it's warm, but it will be getting warm. You must put parentheses around the base whenever the base is a negative number and whenever the base is a fraction. And also, and this might be in the updated version of the guided notes, when your base is an expression, also put it in parentheses. So again, if your base is a negative number, please put it in parentheses. If your base is a fraction, please put it in parentheses. And if your base is an algebraic expression, put it in parentheses. The other thing that's going to be really important here, and I'm just going to put some highlights next to these. Again, these double snowflakes mean this is important and something students frequently forget. Then I'm just going to put some yellow dots in this box. It says any number raised to the 0 power is equal to 1. It's not equal to 0. It's not equal to the base. Any number to the 0 power is equal to 1. That's going to be a really important fact that's going to come up a little bit later. So our first set of examples, we're going to write each expression using exponents. So in number 1, I have 5 times 5 times 5 times 5 times 5 times 5 times 5. This is equivalent to 5 to the 7th power since I have 7 5s being multiplied. Base is 5, exponent is 7. Number 2, I use parentheses for multiplication here. Negative 7 times negative 7 times negative 7 times negative 7 is negative 7 in parentheses. Those parentheses are essential to the 4th power. Our base is negative 7 and our exponent is 4. Number 3, 1/3 times 1/3 times 1/3 is 1/3 to the 3rd power. Notice how I have the 1/3 in parentheses to indicate that that entire fraction is to the 3rd power. So 1/3 is my base, 3 is my exponent. Let's throw in some variables. In number 4, we have d times d times d times d times d. There are 5 d's being multiplied, so this is d to the 5th power. Base is d, exponent is 5. In number 5, we have a times b times b times b times b times c times c. That will be a to the 2nd power times, or you don't have to have a multiplication sign there, b to the 4th power, c to the 2nd power. We have 2 a's, 4 b's, 2 c's, so a squared times b to the 4th times c squared. Number 6, negative 3 times negative 3 times d times d times d is negative 3 in parentheses to the 2nd power, since that base is negative, times d to the 3rd power, or d cubed. It's really important that you either put a multiplication sign in this space right here, or don't put anything at all. Sometimes students will put plus signs there, and we do not want to add negative 3 to the 2nd power and d cubed, so be careful. Number 7, this is where we have an expression that is our base. X minus 2 times x minus 2 is x minus 2 in parentheses to the 2nd power. Our base is x minus 2 and our exponent is 2. And finally, from this group number 8, we have t plus 4 times t plus 4 times t plus 4 times t plus 4. This will be t plus 4 in parentheses to the 4th power. Our base is t plus 4 and our exponent is 4. All right. We also have a box where we need to think a little bit about math. The answer to negative 3 to the 4th power is different than the answer to negative 3 in parentheses to the 4th power. What is the answer to each? Why are the answers different? Take a moment and think about that. You can pause the video. When you're ready, restart it, and we'll discuss the differences. So this is a really subtle difference. -3 in parentheses to the fourth power. Your base is -3 and your exponent is 4. So that's -3 times -3 times -3 times -3. Each -3 times -3 gets us 9. So -3 times -3 is +9. -3 times -3 is +9. And 9 times 9 is 81. So our final answer there is +81. Now, if we have -3 to the fourth power, our base is just 3. So we have 3 to the fourth power, which is 3 times 3 times 3 times 3. And this negative sign, which I'll highlight in blue, just kind of hovering in front of our answer. So 3 times 3 is 9. 3 times 3 is 9. We've got that negative, again, just hovering in front of our work and our answer. 9 times 9 is 81, and we just tack that negative in front of it. So the answer to this right here, -3 without parentheses to the fourth power, is -81, whereas -3 in parentheses to the fourth power is +81. If you plug into your calculator -3 without parentheses to the fourth power, most calculators are going to give you -81. There are a few that assume there's parentheses around that base of -3, even if you don't have parentheses there. Most of them, though, will give you the answer of -81. It may be worth trying. If you put parentheses around the -3, it should definitely get you +81 since your base is -3. I did state a little bit more here. I said the answers are different because one expression has the negative inside the parentheses, indicating that that base is negative, while the other has the negative not in the parentheses or outside of the parentheses or not in parentheses at all. All right, so let's evaluate some expressions. We still have to use order of operations. So remember that exponents come after parentheses or grouping symbols in the order of operations and before multiplication or division in the order of operations. So in number 9, I have 5 times 3 squared. I need to start by doing 3 to the second power. Since that's an exponent, I don't have any parentheses or grouping symbols. So we're going to do 5 times 9 since 3 squared is 9. Final solution is 45. Again, we've got to follow those order of operations. We're doing this right here without calculators because really we're going to keep the numbers pretty simple. Number 10, 15 divided by 3 times 6 minus 4 squared. Let's start with the exponent since we don't have any parentheses or grouping symbols. 4 to the second power is not 8, it is 16. So we have 15 divided by 3 times 6 minus 16. I did my 4 squared. Now for multiplication and division, we work in order from left to right. So let's do 15 divided by 3 next, which gets us 5. We have 5 times 6 minus 16. Let's do our multiplication first. So do 5 times 6. That's going to get us 30 minus 16. Final solution will be 14. Again, the numbers here are really easy, so you shouldn't need a calculator for these. Number 11, we have 48 divided by 2 cubed times 3 plus 5. We want to start with those exponents again. 2 to the third power is 2 times 2 times 2, or 8. So we have 48 divided by 8 times 3 plus 5. Let's work left to right with that multiplication and division. 48 divided by 8 is 6. So we have 6 times 3 plus 5. 6 times 3, of course, gets us 18. And finish this off by doing 18 plus 5, which is 23. Don't forget, if you need to pause the video at any point to copy these things down, feel free to do that. Let's move ahead to question number 12. 4 times 3 in parentheses to the second power all over 9 plus 3. So I would start by doing the parentheses or grouping symbols here. 4 times 3, of course, is 12. You can drop those parentheses or grouping symbols here since we calculated or evaluated 4 times 3. The other thing I did in the same step was I did 9 plus 3 to get our 12 as our denominator. Next thing, let's do 12 to the second power. 12 to the second power is 12 times 12, or 144. So I have 144 over 12. Remember that fraction bar represents division. 144 divided by 12 is a final solution of 12. So question number 13, that numerator looks pretty similar, except I don't have parentheses here. So I actually need to start this one by doing 3 to the second power, those exponents. 3 to the second power is 9, so my numerator is 4 times 9. My denominator, I also did in that same step 3 times 2, which gave us 6. Let's go ahead and do 4 times 9 as our next step. 4 times 9 is going to get us 36 over 6. Remember that fraction bar represents division. 36 divided by 6 is a final solution of 6. All right, moving right along. Number 14, 5 times 4 to the 0 power. You need to remember that anything to the 0 power is equivalent to 1. It's not 4, it's not 0, it is 1. So replace 4 to the 0 power with 1. 5 times 1 is 5. If you're wondering why any number to the 0 power is 1, we'll talk a little bit about that when we do negative exponents in our next unit. Number 15, 12 plus 9 to the 0 power. Don't forget, anything to the 0 power is 1. So replace 9 to the 0 power with 1. This becomes 12 plus 1, which of course is 13. All right, we also want to evaluate some expressions using variables or algebraic expressions. So in number 16, I have g to the 5th power, and it tells me in the directions that g equals 3. So this is equivalent to 3 to the 5th power. That is 3 times 3 times 3 times 3 times 3. What I did was I grouped some of my 3 times 3's together. So 3 times 3 here, which gave us 9. And then we have 3 times 3 here, which also gave us 9. And then this lonely 3 back here. 9 times 9, of course, is 81. So if I have 81 times 3, that's 243. That's not too difficult to do. Do 80 times 3 is 240. And then 1 times 3 is 3. Add them together to get 243. Number 17, be careful with this one. We have 5g squared. This is 5 times g, which is 3 to the 2nd power. Don't forget, you've got to do those exponents first. The heating, air conditioning just turned off, so it got a little bit quiet in the background. 3 to the 2nd power is 9. Let's go ahead and do 5 times 9. Final solution is 45. All right. Number 18, we have g to the 2nd power minus m. I just recopied these directions over again, so we had them. Replace g with 3, replace m with 9. So we have 3 to the 2nd power minus 9. Let's do our exponent. 3 to the 2nd power is 9. 9 minus 9, of course, gets us 0 for our solution. Number 19, hm squared. That's h times m squared. Replace h with 1. Replace m with 9. Do that exponent here. 9 to the 2nd power is not 18, it's 81. Flip those digits around. 9 times 9 is 81. Do 1 times 81. Final answer is 81. All right, moving right along. Number 20, we're going to replace h with 1. So we have 4 and then in parentheses 2 times 1 plus 1 all to the 2nd power. In those parentheses, follow order of operations. Do 2 times 1, which of course is going to get us 2. 2 plus 1, of course, is going to get us 3. So we now have 4 times 3 squared. You can keep the 3 in parentheses if you want. 3 squared, we've seen it so many times by now. You better not say it's 6. It is 9. So we have 4 times 9, and our final solution will be 36. Number 21, replace m with 9. So we have 9 to the 0 power plus 9. Anything to the 0 power is 1. So we replace 9 to the 0 power with 1. 1 plus 9, of course, gets us 10. All right, number 22, evaluate or find a numerical answer to 2/3 to the 3rd power. So I would just write this as 2/3 times 2/3 times 2/3. Multiplying fractions, you just multiply straight across. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Final answer is 8/27. Number 23, evaluate negative 1/3 to the 2nd power. That's negative 1/3 times negative 1/3. Remember that a negative times a negative is a positive. 1 times 1 is 1. 3 times 3 is 9. Final solution, positive 1/9. Got to see some multiple choice as well. What is the answer to 4/5 to the 2nd power? Well, start by writing that as 4/5 times 4/5. Multiply straight across. 4 times 4 is 16. 5 times 5 is 25. What answer does that match up with? Well, it's 16/25. Our solution should be letter C. Number 25, last example here, which involves some patterns. A bacterium cell doubles every 3 minutes as shown in the table below. Which expression represents the number of cells after 45 minutes? So you can continue this chart all the way until you get to 45 minutes. You notice that we're adding 3 every time. Or you might actually notice that if we take our time in minutes divided by our exponent, we always get 3. So 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. 12 divided by 4 is 3. So if I know that I'm looking at 45 minutes, take 45 divided by our exponent, or 45 divided by 3, that's going to get us 15. Sorry, I'm dividing that in the wrong order. We want to take our 45 minutes, divide that by 3, and that is going to get us the exponent that we're talking about here. So 45 divided by 3, following that pattern, is going to get us 15. So we are looking for 2 to the 15th power. And again, you could continue this pattern the whole way through if you wanted to, but if you do notice that your time in minutes divided by your exponent is always going to get you 3, figure out you can do 45 divided by 3 to get an exponent of 15. You could also use your answer choices. 45 divided by 15 you know is 3. 45 divided by 45 is not 3. 45 divided by 5 is not 3, and 45 divided by 10 is not 3. The only one that when you take your minutes divided by your exponent that gets you 3 is choice A, 2 to the 15th power. All right, so it's a really quick overview of exponents, something that we already saw this year, things that I know you've seen before as well. We're going to build on this in this unit, though, and get into some algebraic concepts. So we've talked about some basics of exponents. We're going to throw in some negative exponents. We are going to multiply with exponents, divide with exponents, work with more of those negative exponents in those properties and theorems and so forth. So we'll be starting to get into some things you're definitely going to see next year in your algebra course. Thanks for listening.